Okay, so let's say we wanted to try to integrate this function right here. All right, this is a piecewise function. It's not even piecewise continuous, it's just piecewise. So we have f of x, which is going to be sine of x between 0 and pi over 2, 5 when pi over 2 is less than x, which is less than pi, and then cosine of x from pi to 3 pi over 2. So let's try to figure out what this graph looks like. Okay, so from 0 to pi over 2, this is going to be sine of x. Now, sine of 0 is 0. So the first part of the wave right here, and it's less than or equal to, so we're going to give a solid dot. Okay? And the height of that thing at that point is going to be 1. And let's just put this point up here at 5. Okay, now this says it's going to be 5 when pi over 2 is less than or equal to x, which is less than pi over 2. So that's going to be open dot right there. Well, we'll just some dot lines right there. Okay, so this is pi over 2 at that point. Okay, and it goes all the way out to pi, and it's still less than, so it's going to be a solid, open dot. Okay, and we'll go ahead and bring that all the way down here. Okay, and then it's going to be cosine of x from pi to 3 pi over 2. Well, what's cosine of pi? You imagine if we do a full turn of the unit circle, so 0 is right here, cosine of 0 is 1. We go to the other side of the unit circle, we're actually at -1. So cosine of pi is actually -1, and it's got a less than or equal, so that's going to be a closed dot right there. And then off to 3 pi over 2, which is going to be 0. Okay. And so when dealing with integrals, we do have the concept of positive and negative area. Okay? When talking about positive and negative area, remember when you integrate velocity, you're going to get position. So what happens when I walk forward and then I walk backwards? Well, the total distance I travel is, there is a distance I travel, but what is my displacement? I'm talking about something like that. My total displacement is 0 because I just walk forwards and backwards. So when you integrate this thing, you're going to get a positive area that's going to be associated with that one, and a positive area that is going to be associated with that one, but you're going to have a negative area that is going to be associated with that one. So if I do the integral of this guy, what am I going to get? We talked about Riemann sums just a minute ago. What am I going to get? I'm going to get a rectangle, okay? Because this negative area and this positive area, they're going to cancel each other out. And so the only thing that's going to be left with is the area of that rectangle right there. And if you think about it, well, what is the area of that rectangle right there? It's got a height of 5. And its base is from pi to pi over 2, so it's got a base of pi over 2. So the integral of this thing better come out to 5 pi over 2. Let's check and make sure that that actually happens. So we're going to do the integral of f of x from 0 to 3 pi divided by 2. And we're going to do this integral with respect to x. Okay. But what we're going to do is we're going to break up this integral into all of its individual pieces. This is one of the good properties of integrals, linearity. Okay? So, what are we going to end up with? We're going to have the integral from 0 to pi over 2 of sine of x with respect to x, and then plus the integral from pi over 2 to pi of 5 with respect to x. And we're also going to have the integral from pi to 3 pi over 2 of cosine of x. these integrals and plug in their boundary points. So remember that whenever you do an integral, the rules for sine and cosine switch, okay? So the integral of sine is actually going to be negative cosine. So that's going to be negative cosine of x evaluated at 0 and at pi over 2. Okay, so we put the, all right, so what you do is you do the antiderivative and then you hold on to your boundary points, okay? And so now I have to think about what is the integral of this guy right here. Okay, so if I do the integral of a constant, it becomes something that's linear. So that would just be 5x evaluated at pi over 2 and at pi. And if I do the integral of cosine, that's going to be plus, now sine of x evaluated at pi and 3 pi over 2. Okay. Now I'm going to plug in those boundary points. I'll write this vertically because otherwise it might be confusing. So this is going to equal negative cosine of pi over 2 and plus cosine of 0 because it has negative. Right. Now plus 5 pi minus 5 pi divided by 2. Okay. And plus now sine of 3 pi over 2. Minus sine of pi. Okay, so after you do the derivatives, it's one boundary point minus the other boundary point plugged into the function just for your antiderivative. So when we're talking about this thing right here, what am I really doing? So negative cosine pi over 2 plus cosine of 0, 5 pi minus 5 pi over 2. I'm taking these three intervals, okay? So I'm doing the antiderivative and evaluating at this point minus this point, then the antiderivative of this function at this point minus this point, and the antiderivative of the third function. Let's see what happens. Okay. So negative cosine of pi over 2. Negative cosine, well, cosine of pi over 2 is going to be 0. Cosine of 0 is 1. And then sine of pi is going to be 0. And sine of 3 pi over 2 is going to be negative 1. So, let me end up with from all of this. Okay. That would be negative 0 and plus 1, and then plus 5 pi minus 5 pi over 2. Okay. And then plus now negative 1 minus 0. Okay, and so I was talking just a second ago about how the areas will end up canceling each other out. What is this guy right here, this negative 1 minus 0? That's that area that is going to be below the axis. So this guy right here is going to have negative 1, this guy right here is going to have positive 1, and this guy right here is going to be 5 pi minus 5 pi over 2. And so this negative 1 and that positive 1 are going to cancel each other out. And what are we left with is 5 pi minus 5 pi over 2. And so the answer to our problem ends up becoming just 5 pi over 2. And so when we do this integral, we just get the area of that rectangle that was in the middle because the other two areas are going to cancel each other out.